Okay, this is F.LE.2, functions comparing linear, quadratic, and exponential models, standard 2. Today we're going to be writing equations of parallel and perpendicular lines. So please define these two terms in your journal. And I have two key concepts that I would also like you to copy in your journal. And these are basically the rules for parallel and perpendicular lines. So on this screen you have the parallel lines. So pause the video, copy that down. And on this page you have the rules for perpendicular lines. So again, please pause the video and copy these down. All right, we are going to determine which lines, if any, are parallel or perpendicular. And as you have read on the last two screens, the key figure here is the slope of the line. So if we know the slope of the line, we will be able to tell if these lines are parallel or perpendicular. So our job is to take all of them, put them into slope-intercept form so we can make a judgment based on their slopes. So line A is already in form, and we see that our m is equal to 5. Line B, we're going to have to do some rearrangement of the equation. So let's stabilize the y. We've done a lot of these this year. Bring that x to the right. And now we need to solve for y, so both sides get divided by 5. So y is going to equal negative, the coefficient in front of the x is an invisible 1, so there's a negative 1x over 5, which is negative 1/5 x. And then you have your 2 divided by 5, which is 2/5. So as you can see here, the slope is, you know what, let's write that above here. So in line B, m is equal to negative 1/5. Line A was 5. And let's go work on line C here. Okay, let's rearrange. So negative 10y stays. The negative 2x goes to the right and becomes positive 2x. And the 0 is just plain old 0, so it doesn't even really exist. We don't need to put that down anymore. Divide both sides by negative 10. So y is equal to, reduce the fraction, we have 2 over negative 10, so that's a negative 1/5 x. And again, we don't have b here, we don't have a y-intercept. We know that this line is going to cross at the origin, so at the 0. And that leaves us with our m also equaling negative 1/5. So now that we see all of the slopes in these three lines, we can make a comparison. So line A is 5, and line B and C are not 5. So line A is not parallel to line B or C. However, if I look at line B slope, see that it's negative 1/5, and line C is also exactly negative 1/5, we can make a statement of line B is parallel to line C because they are identical slopes. Now, if we were to think about perpendicular lines, we know that the rule is that two lines will be perpendicular if their slopes are the opposite reciprocals. So if I'm looking at 5 here, I know that the fraction of 5 is 5 over 1. And the reciprocal of that would be 1 over 5. And notice that the signs are indeed opposite. So I had a positive 5. Now I have a negative 1/5. So our final statement about perpendicular lines, I would say that line A is perpendicular to both line B, to lines B and C, because both of them are negative 1/5, which is the opposite sign and reciprocal of 5. All right, now we're going to actually write an equation of the line that passes through this given point, and it is parallel to the line of y equals 2x plus 2. So we're going to create an equation just given this information and the slope of the line given, which was a 2. So if we're looking at parallel, I need to know what the slope is to help me generate this new equation. So if I know that my m in my new equation must be exactly the same of the equation they gave to me, I know that my new slope has to be 2. And now we set up our slope-intercept form and plug in the information that they give to us. So I know that my y is 3. My m has to be in the new equation exactly the same. So I have to substitute in my 2. My x is negative 1. And I don't know where this line is going to cross the y-axis. So let's go figure out where that is. So add 2 to both sides. So 5 is equal to b. And my new equation that is parallel to y equals 2x plus 2 is going to be y is equal to 2x. And then we had our plus 5. And our new equation is created. Now let's go look at that on a graph. I already have the first equation graph for you. This was the y is equal to 2x plus 2. Notice our b is at 2 and my slope was 2. Rise 1, 2, rise 1. So we have up 2, right 1, up 2, right 1. So there's our slope of 2. And now let's go create our new equation, which was called y equals 2x plus 5. So if I go to my b, which is 1, 2, 3, 4, 5, and my slope was identical because they're parallel, that means I rise 2 and run 1, or I fall 2 and go left 1, fall 2 left, fall 2 left. And you see here we have lines that will never intersect each other because their slopes are the same. Let's just clear off those marks here. Okay, parallel lines. The last one, we are going to create perpendicular lines. And again, as we know, the slope is the main figure in determining our perpendicular lines. So if I see here that the given slope is 5, I know that my new slope will have to be the opposite of the slope, which was positive, so it's going to have to be negative. The number 5 is a fraction we know is 5 over 1, so the reciprocal of 5 over 1 is 1/5. And we are going to use that information to help create this y-intercept so we see where the perpendicular lines will meet each other. So here we go again. Take the given information and let's go solve. All right, So your y value is 1. Your new slope has to be what we came up with, which is negative 1/5. Your x is 5. You know, since we're doing fractions, I'm just going to put it as a fraction. So 5 plus b. All right, now we have 1 is equal to a negative times a positive is a negative. I can cross cancel my 5's and make them into 1's. So we have 1 times 1 over 1 times 1, and we know that it was a negative, so we have a negative 1 plus b. And if we're solving for b, we need to get this negative 1 to the left, so we add 1. So we're going to end up with b equaling 2. And our final equation will look like y is equal to my new slope, which is the opposite reciprocal, and our b. And we're going to go graph that and see how that's going to look in terms of a perpendicular line. So negative 1/5 x plus 2. All right, let's go graph that. So if I go to plus 2, that's my b, 1, 2. And now I have to do my slope, which was negative 1/5. So if I were to go up 1, I would have to go left 5. So up 1, 1, 2, 3, 4, 5 to the left, or down 1 and right 5. 1, 2, 3, 4, 5. And let's connect those lines. Let's try to get that. And we will get rid of our annotations so you can see that we have a set of perpendicular lines. And if I want, I can draw in a little 90-degree angle just to prove that to you. We have 4 90-degree angles that kind of wrap around this blue and pink line that we created. In your journal, please define the given terms on page 2 of the flip chart. Write a few things that you learned that are new to you. And if you are having any questions, bring those questions to class, and we will be working on some of those fun application problems that deal with parallel and perpendicular lines. See you in class.